Object-oriented programming is one of those things that don't make sense until you actually use it. And then all of a sudden, it's like the world is made of candy. I'm not even kidding. But before I get into that, let me tell you a story. A couple of years ago, I was working on an app with an amazing team of developers. We were building a pretty complex system for company's internal use, and we were having trouble getting everything to work right. But then our lead developer introduced us to OOP, and suddenly everything just clicked into place. If you want to know what was the main tip that he shared with me, stick around till the end of the video. So, what's the deal with OOP? OOP stands for Object-Oriented Programming. In simple terms, object-oriented programming is an approach to writing code, where we think about the different parts of a program as objects that interact with each other. These objects represent things in the real world or abstract concepts, but more on that in another video. It's based on 4 core principles: encapsulation, abstraction, inheritance, and polymorphism, often referred to as the 4 pillars. These principles help us organize our code in ways that make sense from the perspective of both humans and computers. They also make it easier for us to deal with changes down the line, which is especially helpful when building software that will have long lives in production environments. They complement each other with solid principles and allow us to write a robust and, dare I say, rock-solid application. But let's take a deep dive into the 4 pillars of OOP. Our first pillar is encapsulation, which is like having a secret vault for your code. Just like a vault protects valuable items, encapsulation protects data and functionality within an object. It hides implementation details from outside access. Imagine you're building a banking application. You create a bank account class that encapsulates the account details and operations. By making the account balance private and providing methods to deposit and withdraw funds, you ensure that the balance can only be accessed or modified through controlled mechanisms. Next up, we have abstraction, the art of simplicity. Abstraction simplifies complex systems by focusing on the essential features while hiding unnecessary details. Let's consider a graphical application with various shapes: circles, rectangles, and triangles. Each shape has its own properties and methods. Instead of dealing with the intricate details of each shape, we can abstract them into a common shape class. Now, let's explore the power of inheritance, our third pillar. Inheritance allows objects to inherit properties and behaviors from parent objects, creating a hierarchy of related classes. Consider a scenario where you're designing a game with different types of characters: warriors, mages, and archers. They all share common attributes and behaviors, but each has its unique characteristics. Inheritance helps us solve that. Lastly, we come to polymorphism, the shape-shifting superpower of OOP. Polymorphism allows objects of different types to be treated as if they belong to a common family. Imagine a scenario where you have a drawing application with various shapes: circles, rectangles, and triangles. You want to create a method that can draw any shape without knowing its specific type. With polymorphism, we can pass a list of different shape objects to the draw shapes method, and it will invoke the appropriate draw method for each shape. This flexibility allows us to write more generic and reusable code that can handle various shapes effortlessly. With all that, we were able to maintain our code better, and from now on, I would never go back to writing code the way I did. Anyway, OOP really helped us out there. It made everything more readable and intuitive, which meant less time spent debugging and more time writing quality code. Oh, and that tip I got from my lead, it was to learn about design patterns. But we will dig deeper into that in the next video. So while we can't say that OOP is the answer to all your problems, and that it's the only way to write good code, we do think it's worth learning about. It has a lot of benefits, but also some downsides, like a mental shift in the thinking process. So consider what you might be trying to accomplish with your project, and then decide if OOP is right for you. If you found this video helpful, be sure to give it a thumbs up and subscribe to our channel for more programming content. Also, don't forget to hit the notification bell so you never miss an update. As always, thanks for watching and happy coding.